Welcome to another episode of Cyber Secrets.
Imagine we just received a USB thumb drive into evidence. The suspect is accused of hacking and violating the corporate communications policy by using unauthorized software, such as Tor. Before we plug in the thumb drive, we first want to add a new key into the Windows registry. This key will tell Windows not to write to USB storage devices that are then plugged in. You do this by going into regedit, and then adding a new key under HKey local machine /system /current control set /control. And the new key is going to be called storage device policies. Now that the storage device policies key has been created, we need to create a dword value. The name of this new dword value will be write protect. Write protect can contain two values, 0 equals off and 1 equals on. To make a quick method for turning the write block on and off, we will export the key and save them to the desktop. Now, let's test the new toggle switch. Watch the registry value in the background as we run write protect on. Once this is done, Windows has effectively turned off writing to USB storage devices, or now is blocking the writes to them, effectively acting as a write blocker. Now you can insert your USB thumb drive into the computer. Now that we have the USB on the system and it's write blocked, open up FTK Imager to make a bitstream copy. First thing that we want to do though is verify that we have the right drive. So we're going to choose physical drive, hit next, and then make sure that we have the right one. See, there's 3 drives here. If you have the wrong drive, you can make a mistake such as making a bitstream copy of your hard drive onto your hard drive. At that point, you're going to be DOSing your own workstation. So at this point, we've just verified that it is the right drive. Now we can right-click on it and then export disk image. Once you export it, go ahead and add. We want to make a raw DD copy. That's a universal generic copy. Here's where you need to document. You document everything. So we're just going to have a generic case number, evidence item number, a unique description, and then after that, put the examiner name. But you want to get in the habit, whenever doing computer forensics, document everything. Go and hit next, and we're going to choose the desktop so we know exactly where it's at. You want to be as anal retentive as possible when you're doing this and put everything into its own subfolder, but because we're just doing it as a demo, we're going to put it onto the desktop to make sure we can find it later. Just call it Forensics Recovery. And on the image size, I like to choose 0 because this makes it to where it's no longer a split image. I'm going to hit Finish, and then at this point, sometimes I do like to create a directory listing so I can look later at all the files that were copied. But at this point, just go and hit Next, and then start the imaging. The imaging takes a long time, so we're going to fast forward through this. Even though it's a 2 gig thumb drive, it still took several minutes. Now it's verifying. So what you want to do in forensics is document everything and verify everything. Once the verification is complete, it'll show us the MD5 hash. The computed hash and the reported hash, they're the same. The SHA hash, computed hash and reported hash, they're also the same. This is good. This is what we want to see. So let's go and close out of here. And then on the desktop, it's made a document file with a forensics recovery dd.txt. We'll open it up. This has all the information that you just added into it. It also has the computed hashes and the verification hashes and when it was acquired. This is important. Again, document everything when dealing with forensics. Let's go and close out FTK Imager. Now we're going to open up Autopsy. Autopsy is a great free resource. It's one of the sayings, you get what you pay for. This is free. You actually get a lot, even though it is free. So go ahead and start a new case. Once we start a new case, we're going to point it to that DD image that we just created with FTK. Go ahead and start a case file. Again, document everything. Go to next. Again, case number, examiner. And if you look at the top left-hand side, it just created a folder called 001. This is the folder where all the data is going to be dumped into. Now, we want to make sure it's an image file. We just created an image file with FTK Imager. So keep it as image file. Now we're going to want to point to that image file. Get FTK Imager. Just created. Let's go ahead and open. And then the time zone that you're currently in. Once you have the time zone, everything else is set. Go ahead and next. And in this window, there's a lot of extra things it'll look for. The one huge benefit is it actually also looks for Thunderbird. That's an email client that a lot of the forensics tools will not look for. So again, at this specific area, go through each one. Even has some pre-allocated text strings that you can even look for, which makes things really nice. It even has the ability to look for hashes, like your National Software Reference Library hash. In this specific area, we'll look for things like IP addresses, phone numbers. So it does some pretty good grep expression searches as well. And what I do like about Autopsy is it does seem to have a little bit less false positives than some of the other tools that I've played with, even the commercial tools. What this is doing, though, in the data carving scope is indexing. So if you've heard the term indexing from any of the other tools, it's basically what it's doing right now. We're also going to want to do the unallocated space in case anything was deleted. So as soon as you start this, this is going to take a long time. If you thought imaging took a while, this takes forever. For example, the indexing on this 2 gig drive took 20 minutes. Now we're going to look for the folder, that 001 folder on the desktop. If you notice how big it is, you can go into the size. It's almost a little bit over a gig for that 2 gig image. So you do need a lot of space for every investigation that you're going to be doing. So some of the features that it has. You can preview the drive just by going up to the data sources, but it also has pre-allocated other items, such as if you see the number for the URLs, the email addresses, the IP addresses, and so forth. But one thing that I do really like about Autopsy, does it a little bit differently than some of the others, is the EXIF, or the metadata. So what EXIF is, that's extra information that they add specifically for graphics. You can even have location services in here. So take a pick on some of these items. For example, this one right here was a Nikon, took it. This one was a Canon camera that took that picture. Here's one from an Aris or an HTC Aris, and that specific one does have location services already inside of it, so your longitude, latitude. So this makes it really easy to verify when and where the picture was actually taken. So now we're going to preview the disk. So at the beginning of this whole scenario, we were looking for any potential evidence of Tor traffic. Immediately, you already see Tor browsers already there. Anything that has an X on the image to the left-hand side, that means it's a deleted file. So we've already found some instances of Tor. We found a lot of deleted content, some related to hacking, credit cards, fake IDs, things in that area. So even just undeleting. So this specific area, when you're previewing, when you have the file names, you can recover any of that content. If it has an X on it, that means it was deleted. The data still may be there, and it still may be what's called undeletable. This is still going to be an unallocated space. However, there's a pointer still going directly to that area. You can have it, though, when you try to recover some items that may not work. For example, here, this is an AVI. Autopsy does have an AVI viewer built in. All the data is there. It's pointing to the right space, but it doesn't have the right codec. This is one of the times where you may actually have to use an external or third-party viewer. So go and export this file out. Once we export it out, we're going to use a program that I like called VLC Player. VLC Player allows you to play video codec that some other players won't let you play. What's also nice about it is that VLC is also a little bit more lenient when it comes to damaged files. So if this file was corrupted in any way, you'll have more of a chance of being able to play it with VLC Player than you would with some of even the commercial tools out there. So we can see it opened up just fine, even though Autopsy was not able to, and some of the other forensics tools are not able to automatically as well. So we'll go ahead and close out of here. Go back into Autopsy. Some of the other things, did want to show you the unallocated space. You could search through that if you had keywords that you wanted to look at. But another thing that's nice about it is it pre-allocates file types, such as images, videos, audio, or archives like zip files. So if we just went into that video section, it has that video that we just opened, along with some flash players. It even has a really good keyword search. The keyword search is very fast, but only because it's already pre-indexed. This is how FTK used to work. It would index first, then allow you to do the searching. Some of the other tools do not work that way and have it to where you can preview quickly or fast, but then you have to search, and it takes a really long time to search. So we just typed in Tor, and as you can see, there's a lot of hits. And this is related to what we were looking for at the very beginning of this demo. Some other targeted items, like IP addresses. If you look at those IP addresses, those look very real, or they look like they're probably not false positives. Some of the other IP address searching utilities that I've seen in the past would look for 3-digit, 2-digit numbers, but then they would go above and beyond the 255 number range. Same thing with IP addresses, URLs, email addresses. But if you look closely, especially with the email addresses, most of them are legitimate email addresses. But when you look at the URLs, it even has .onion addresses. A .onion address is only found on the Tor browser network, or the Tor network, through onion routing. So this goes, again, back to what we're looking for at the beginning, any evidence of Tor traffic. That's one way for doing forensics within a budget.
The Cyber Secrets web series covers computer forensics, hacking, and everything in between. Thank you for your continued support of Cyber Secrets. With the reboot of the different series, we want to ask if you have ideas for future content or suggestions for improvement. Please let us know. Click subscribe for new episodes of Cyber Secrets.